Good evening everyone and welcome to the Q&A session 22 from the chapter of electrostatic potential and capacitance. The topic is the calculation of potential difference between the 2 points due to a uniformly charged long wire. So this session is based on the session number 21 in which we have derived the equation for the potential difference between 2 points due to an infinitely long uniformly charged wire. And this formula was, that is VB minus VA, this is equal to minus lambda divided by 2 pi epsilon naught natural logarithm of RB upon RA. So this was the formula which we had learned in the previous session. So this formula is related to this figure. Let us say this is a point A and this is a point B and this is a uniformly charged wire which is having a linear charge density of lambda. Now let us consider the radial distance of this point A from this wire as RA and the radial distance of this point B from this wire is RB. Now in this question there is an infinite wire having a linear charge density of 2 microcoulomb per meter. So we have to find the potential difference between 2 points which are 1 meter and 3 meter away. So here RA is equal to 1 meter and this RB is equal to 2 meter. So simply we will be using this formula in order to find the potential difference, that is VB minus VA. This will be equal to minus lambda upon 2 pi epsilon naught. So what I will do is that I will multiply this value by 2 in the numerator and the denominator. So I will be getting minus 2 lambda divided by 4 pi epsilon naught. And the natural logarithm of now RB here is equal to, sorry, this is not 2 meter, this is 3 meter. So this will be equal to 3 by 1. So this will be the natural logarithm of 3. So now here 1 by 4 pi epsilon naught is the numerical value of 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9 and multiplied by 2 multiplied by lambda. Now here the lambda, this lambda, that is the linear charge density, is given as 2 microcoulomb per meter. So in coulombs this will be 2 into 10 to the power minus 6 coulomb per meter multiplied by the natural logarithm of 3. So the value of the natural logarithm of 3 is, this is approximately equal to 1.09. So this is equal to, let's say this is 1 point, I can take it as 1.1. So from here the potential difference between the 2 points which are situated at a distance of 1 meter and 3 meter from this uniformly charged infinite wire, this will be equal to 9 into 2 is equal to 18 into 2, 36. So 36 into 1.1, this is equal to 39.6 into, this is equal to 10 to the power 3 volts. This can be further written as minus 39,600 volts, or simply this can also be written as minus 39.6 kilovolt. So the potential difference between the 2 points which are 1 meter and 3 meter away from this infinitely long wire of linear charge density 2 microcoulomb per meter is equal to minus 39.6 kilovolt or 39,600 volts. So thank you very much for joining this session. In the next session I will be coming up with a different topic from the same chapter of electrostatic potential and capacitance. So till then, have a nice day. Bye.